Hello students, welcome back to our physics lesson channel. My name is Robot Dimisechu and your local teacher name is Mr. M. He will review today's lesson at the end of this video. Let us start our first lesson. 1. Introduction to Physics. Physics is the fundamental science that seeks to understand the fundamental principles governing the behavior of the universe. It explores the fundamental components of matter, the forces that act upon them, and the resulting motion and interactions. The goal of physics is to formulate laws and theories that can describe and predict the behavior of objects, from the smallest particles to the vast expanses of the cosmos. 1.1. Physical quantities. In physics, a physical quantity is a characteristic or property of an object or phenomenon that can be measured or calculated. These quantities can be classified into two main types: scalars and vectors. 1. Scalars. Scalars are physical quantities that have only magnitude, size, and no direction. Examples of scalars include mass. It only has a magnitude and is measured in kilograms, kilogram. Time. It is measured in seconds, s. Temperature. It is measured in degrees Celsius, degree C, or Kelvin, K. 2. Vectors. Vectors are physical quantities that have both magnitude and direction. Examples of vectors include displacement. It is a vector quantity that represents the change in position of an object. Velocity. It is the rate of change of displacement with respect to time and has both magnitude and direction. Force. It is a vector that causes an object to accelerate and is measured in newtons, N. Physical quantities can further be categorized into fundamental and derived quantities. 1. Fundamental quantities. These are basic quantities that cannot be defined in terms of other physical quantities. Examples include length, mass, time, electric current, temperature, amount of substance, and luminous intensity. 2. Derived quantities. These are quantities that are derived from fundamental quantities through mathematical relationships. For example, speed is derived from the fundamental quantities of length and time. In addition to scalar and vector quantities, there are also tensors, which are quantities that have multiple indices and can represent more complex physical properties. Examples of tensors include stress and strain in materials. Measurement units are used to quantify these physical quantities, and the International System of Units, SI, is the standard system of units used in physics and most scientific disciplines. Thank you for watching and your local teacher review today's lesson. See you in the next lesson.
Hello students, my name is Mr. X, and previously Robot Dimisechu teach you about physical quantities. Let me review today's lesson. Today we have seen physical quantities divided into two. 1. Scalar physical quantity. 2. Vector physical quantity. A scalar physical quantity have only magnitude and no direction. Some of the scalar physical quantities are the following: distance, for example, symbol S, or sometimes we get S symbol. In some books we see S. Measured in meter, or its unit is meter. Speed, the symbol V, measured in meter per second. Mass, symbol M, measured in kilogram, or kg, the symbol kg. Time T, measured in seconds. Temperature T, capital T for temperature. Sometimes in physics don't confuse. Small t for time, capital T for temperature, measured in Kelvin. Energy E, measured in Joule. Area A, measured in meter square. Volume V, measured in cubic meter cube. Electric charge, symbol Q, measured in Coulomb. These are scalar physical quantities. The second vector physical quantities, this displacement. We can define displacement as the change in position with both magnitude and direction. Displacement we can write as with arrow. Most of the time we put arrow for vector quantities. For distance we can write simply without arrow, or d like this. This distance, this one displacement, this one distance without arrow. Velocity, rate of change of displacement with respect to time. That means for velocity we have v symbol with arrow. In general, vector quantities we represent with arrow, and the symbol v for the velocity. Acceleration a with arrow, force F with arrow, momentum P with arrow, torque P with arrow. We will see detail in the future. On the other part, we have seen also physical quantities divided into two. One, the fundamental physical quantities, and the second, derived physical quantities. These fundamental physical quantities are length, for example. Its symbol is L, measured in meter, mass M in kilogram, time T, measured in seconds, electric current, symbol I, measured in ampere, temperature, capital T, measured in Kelvin, amount of a substance, measured in mole or its symbol N, luminous intensity IV, and measured in candela. These quantities form the basic for international system of units, which is the modern form of metric system used in most countries around the world, and other derivative quantities and units can be expressed in terms of these fundamental physical quantities. For example, velocity derived from length and time. We already this on if we see derived physical quantities. The speed, we express them in the form of these fundamental physical quantities. All right, let us see one example. Let's take speed. Let me change my writing. Okay, look, speed is a derived physical quantity. Speed is equal to distance over time. Then distance is it a derived or a fundamental physical quantity? Distance is a fundamental physical quantity. Look, then distance is fundamental physical quantity. Again, time, again, it's a fundamental physical quantity. We express derived physical quantities in terms of fundamental physical quantities. That's the difference between fundamental and derived. Thank you for watching. If you have any question, write down please on the comment section of this video. We will see in detail one by one. Again, robot demonstration will teach you a lot. Thank you for watching. See you in the next lesson. Bye bye.